At the IGPP Freiburg, we are focusing on the experience of time. So we're interested in how the subjective experience of time changes with our sense of self, for example, in the flow state, or in opposition in states of waiting where we feel very much ourself and then time drags, time slows down. So we'll be doing several studies on trying to get people actually in flow states through video gaming, and thereby actually being able to have subjects lose their sense of self and time. And this we will be doing behaviorally while people are playing the game, and also while recording the EEG.
Video games are very well known for making time fly. This is because games are associated with a psychological state called flow. In the state of flow, we lose ourselves in an activity and we also lose track of time. And video games are very good at producing this state, which can also be produced by other activities, of course, like dancing or playing sports. But not every game works the same way for every player, so we're trying to understand which aspects of games are best at eliciting flow. And we're also comparing different technologies for playing games, like, for example, virtual reality and a computer screen. Games like Thumper, for example, can be played both in VR and on a computer screen, so we're doing experiments with this game to be able to compare these two technologies and see how they both affect time, or if they affect time perception in different ways.
Here we are trying to find possible brain mechanisms involved in the state of flow, utilizing EEG and also other electrophysiological signals. We will have game players here playing commercial games, and we will analyze their brain signals along with their electrophysiological signals in order to find possible markers for the flow state.
We're also interested in understanding the other extreme of time perception, that is, when time doesn't seem to pass. And that's exemplified at best by a waiting room scenario, when we get bored and we start expecting the next interesting event in our lives. For that, we've created a virtual reality waiting room, and we'll make subjects wait in the room and then see how that affects their time perception. The results of this experiment will be also compared with the results of other experiments that were conducted already in real waiting rooms, and we will see how then virtual reality compares to reality in the same waiting scenario.